Hello everyone. From today onwards, we are starting with class 12 Physics HSC Board's first chapter's revision. So let's begin. The way in which I'm going to tell you how this chapter can be revised in this way. So first thing, this is the mind map that I have made. So first, what is circular motion or what is kinematics of circular motion? Let's start with that. So basically what you want to know is what is kinematics. So kinematics is nothing but the branch of physics. The very general definition I am giving it to you, a branch of physics in which we study in which we study the motion of the object. Motion of the object. Now what do you study in the motion? I hope already you know it. Motion of the object, which includes following certain physical quantities which help us to study the exact motion or to describe the exact motion of that object, of that person, of anything. So the first very important that we must know the position. Then second is the distance covered by that object. Then that means we are just measuring the magnitude, and the next obviously displacement. That means we are measuring the distance covered along with specifying the direction of motion. Then it comes velocity with which the object is performing motion, whether it is a circular motion, whether it is a linear motion, or whatever kind of motion. We are studying these basic quantities in there. Next comes acceleration. And here I am writing the last but not the least, force and acceleration, how they are related in different types of motion. Yeah, this is about kinematics. Now, in a circular motion, the very baseline that if we want to study all this, we must know the analogy between the linear motion and the circular motion. Okay, so let's open the new page here. So, analogy between circular motion, or I would like to write it in this way, linear motion and circular motion. And circular motion, right? Means how do we can replace the symbols, the physical quantities from linear motion to circular motion, or how we can use or how we can translate those physical quantities, or how we are using those physical quantities. As a baseline is linear motion, but we are using it in circular motion. So here I write linear motion, and here let's write about circular motion. So linear motion, the first is a distance covered, first quantity, distance covered by that object. Here also distance covered. Now when I write distance covered below that circular motion, I am saying about a arc length. Arc length. The symbol that we use is S, and here also S. Second thing is displacement. Now we know distance covered is a vector quantity. Displacement, sorry, very sorry. Distance covered is a scalar quantity and displacement is a vector quantity. So here I write, or here I am supposed to write S bar. Here also, now in case of circular motion, we know it is nothing but the angular displacement, and we denote it by theta bar. If I have to write the magnitude, it's simply theta. Third one, here it is displacement, obviously the speed. We denote it by symbol V. Here it is angular speed. Omega, that's it. Because we are writing speed, no need to put bar over the symbol. Fourth is velocity. This is V bar, and this is angular velocity. That is omega bar. Then fifth one is acceleration. Acceleration. So it is a bar. But now in case of circular motion, we have two kind of accelerations that we know. So I'll just write it in this way. Acceleration here, first type, tangential acceleration, which is in the direction of tangential velocity. So tangential acceleration, which we denoted by symbol A T bar. And the second one, which is a very known thing, is radial or centripetal acceleration. Radial or centripetal acceleration, which we denoted by AC bar. Yeah. Now here, in case of linear motion, we know next thing, next physical quantity is a force, which is denoted by F bar. And here it is torque, which is denoted by tau bar. So if I have to write the formulae for this, since these are important physical quantities, we do write F bar is equal to M A bar. And here we have tau bar is equal to I alpha. This is of course one of the formulae. Later on, wherever needed, we will discuss the another one. Yeah, force and torque. And now this is just kind of a comparison of the symbols that we are going to use. Now coming back to that chart, or to that the mind map kind of things, I should say the kinematical equations in both, how they do like, right, how these are written in linear as well as in circular motion. So here I just give the heading kinematical equations. kinematical equations. So the first equation in linear motion we know is V bar is equal to U bar plus A bar T. The same thing in circular motion or rotational motion, we can figure it out as omega bar, which is omega 0 some omega 0, which is the initial angular velocity, plus here alpha t, alpha bar t. Next is about a distance cover. So S is equal to U bar T plus half A bar T square, or if you want to write it in terms of vector quantity, we call it a displacement. Here in case of rotational motion or circular motion, we write it theta bar is equal to omega 0 bar T plus half alpha bar T square. And the third one, V square, which is equal to U square plus 2A S, and it goes in circular motion like omega square is equal to omega 0 square plus 2 alpha theta. Yes, noted? Noted? Now let's move ahead. Now, two types of forces are there that we will see at that places: centripetal force, centrifugal force. Now see, we are doing a revision, so not the entire topic I will teach over here, but what points that you should know wherever, or which points you should revise while studying the rotational dynamics, the first chapter, class 12 physics, is centripetal force, centrifugal force. So you must know the definition first of both the things, then how the formula differ, because it differs in sign. Centripetal force, if I have to write, then it is like, here I write FCP, which is minus M R omega square R cap. What it indicates? Negative sign indicate it is oppositely directed to that radius vector. And if I am writing about centrifugal force, FCF bar, here I write, you must give this plus sign over there, plus M R omega square R cap. Then we will have to study the vertical circular motion, or you have studied, as we are doing the revision, you can say, or I can say that you know or you are aware of this, we are studying vertical circular motion. Now lot many topics, subtopics are there. Here I am just shortlisted those velocities at different positions on that vertical circle, and difference in tensions between highest and lowest position. These are the important derivations that could be asked in a board exam. Right? Getting it? Chalo. Next. Now this is somehow the mind map that I have prepared. So the next thing, next time we will start with the horizontal circular motion, because that is a first subtopic that we must study under the section Rotational Dynamics Revision Part 1. Yes. Thank you.